You've talked about probability since you were 5th grade, at least probably before that. A probability is nothing more than the likeliness of something happening. Likeliness of something happening. And probability generally is expressed or shown in fraction form. Okay. The probability that somebody, if you're having a baby, the probability is 1/2 that it'll be a boy, 1 out of 2 times. Although I'm not so sure. If in reality it's a half, I don't know if there's more boys and girls in the world, it's probably one way or another, something like that. But there's also this here, and this is kind of where they get the fraction scale from. If you draw a line here, and you make this 0, if something has a probability of 0 happening, okay, it is basically impossible. The probability that today is Thursday is 0. It's impossible that today is Thursday. Is it for certain it is. The probability of something over here that's 1 is what? Possible? No, it's more than possible, it is absolutely certain. Okay, the probability that I'm now writing in red is certain because it is. Can't change it.
Then it's orange.
Yeah, it's red. Okay, now, here we have the probability 1/2, right? Split right down the middle is basically, it's as likely as not. Likely as not. If it's below 1/2, we just say it's unlikely. And if it's above 1/2, we say it's likely. Unlikely, likely. Okay, and again, when you're talking about probability, if something has a 7/8 probability, it's likely to happen, but it's not a guarantee, it's not a sure thing. Okay, if people make the lottery, it makes all sorts of money based on the probabilities of people not being able to pick numbers or picking numbers or whatever. It's all math and calculated out, so there's no possible way people who run casinos or lotteries can ever lose. Which is a good lesson to you. If the lottery has a little saying that says somebody is going to win, it might as well be you. Yes, somebody will win, but the probability or the odds of you winning are so much out of your favor, you might just as well give the people your money. Okay, yes, somebody's going to win, but, yeah. You have a better probability or likelihood of finding $10,000 probably than more than that's neither here nor there. Now, when we talk about probability, though, mathematically, here's kind of what we do. Okay, let's say I'm flipping a coin. I've got this coin, and it's whatever Abraham Lincoln or whoever he is. Usually, when we talk about probability, rather than writing out the long word probability, we use the capital letter P to stand for probability. If you see that there, and then in parentheses, we put what we want to happen. In other words, the probability of flipping a head. Okay, rather than me writing out those words, probability of flipping a head, I can just abbreviate it like this. Probability, this is the outcome that I want. Probability of flipping head, then I would go equals. And the fraction you make is simply, on the bottom goes how many different outcomes there are. How many different outcomes. And on the top is how many of the one you want. You want. So if you're talking about flipping a coin, how many different options are there when you flip a coin? Well, you either flip a head or a tail, so there's only 2 choices. How many of those 2 choices are a head? Only one of them. And that's where your probability of flipping a head is 1 out of 2. Half of the time you should get a head. Now again, if you flip the coin 10 times, you should. The probability says that you're going to get 5 heads and 5 tails, but in reality, that may not happen. Okay, you might get 7 heads. You might get all heads. Okay, but the probability is this. Okay, and the more times you flip it, generally speaking, the more times the closer it's going to get to being exactly 1/2. In other words, if I flip the coin 1,000,000 times, okay, it's pretty likely that I'm going to end up very close to 500,000 times getting the head. Much more. It gets much closer as you do that rather than just flipping it once. If you flip it once, it could happen. It might not happen. If you flip it 1,000,000 times, more than likely you're going to get very close to 500,000 times. That's why if you're doing an experiment for science or whatever, okay, the more times you try it, the more sure you can be that your results are accurate. You know. Yes, Haley.
What is the top part say?
How many of what you want?
Okay.
What you want. Now, let's take another example here. Let's say you're rolling a die, or is it a dice?
A die.
Two of them is a die. One's a dice, two, pair of dice.
Dice. It's an ace.
Okay, if I asked you what the probability of rolling a 6 is, okay, the basic gist is that is you say, well, how many different, when you roll a cube, you have to know some things about this stuff. How many sides does a cube have? 6 of them. Of those 6 sides, how many of them are the number 6? Only 1. So 1 out of 6 times you should roll a 6. Now I could change this to say, what about the probability of rolling an odd number? Well, you still have 6 sides to the dice, or the die in this case. How many odds are there? Well, you have 1, 2, 3, 4, 5, 6. Those are your possible choices. 1, 2, 3 of them are odd. So your probability of rolling an odd number is 1 out of 2, because you do reduce it. Does it say what?
Does it say dad?
Yes, it does.
So I. How do you say that?
Something that looks like a D.
I thought it said dad.
Perfect. Now, here we go. Here's speed notes. Next one.